We are joined today for this presentation by two researchers, Adil Latif and Gayatri Krishnamurthy. These researchers are presenting from the National Laboratory of the Rockies and will be sharing insights into the ERAD tool. Without further ado, I will pass it over to Gayatri.
Thank you, Sophie. Hello, everyone. Good morning. I'm Gayatri Krishnamurthy. As Sophie mentioned, I'm a researcher at the National Laboratory of the Rockies. I want to set some expectations for this session. This isn't meant to be a software walkthrough. It's really about how resilience planning is evolving and where ERAD as a tool fits in that process. Next slide, please. Okay, let me start by grounding us in the reality that utilities are operating in today. At the top, you see the big picture, over 3,000 distribution utilities, all with different constraints, regulatory environment, and customer bases. So right away, there's no one-size-fits-all solution here. Now layer on to the next two bullets, we have aging infrastructure and new load growth. So utilities are not just maintaining systems, they are simultaneously expanding and modernizing them. And then you have multiple hazards affecting the same system. So let's say flood, wildfire, wind. These are not independent anymore. They are overlapping and compounding. If you look at the figures, the bottom left chart shows the steady increase in distribution investment getting into the $50 to $60 billion per year range, trending toward over $1 trillion by 2050. So these are not small decisions. And on the right, you see both the increase in the billion-dollar disaster events and the outage trends, which are clearly dominated by the weather-related impacts. So hazards are not just theoretical, they are directly driving outages. So when you put this together, we have the large-scale investments, increasing hazards, and asset-level decisions. The challenge is not just understanding risk anymore. It is making consistent decisions across all of this complexity. And that's exactly the space ERAD is designed to operate in at the intersection of the hazards, assets, and the investment decision. Next slide, please. This slide is really about why this conversation is happening now and not 5 or 10 years ago. First, extreme events are increasing in both frequency and severity, and the images here are just meant to reflect that range from storms to wildfires to flooding. Second, our distribution system are driving the majority of these outages. So while a lot of attention historically has been on the bulk system, the impacts that customers actually experience are happening at the distribution level. Third, utilities are investing at an unprecedented scale. We just saw the numbers on the previous slide, and those investments are happening right now. And the last point is really important. These are long life decisions. Once you invest in an infrastructure, that decision is locked in for decades. So when you combine all of this, you get to the statement at the bottom. Utilities are making billion-dollar decisions under deep uncertainty. And that's where ERAD as a tool plays a central role. It's not just organizing different information, it is actually helping quantify how hazards translate into system level impacts and how different investments perform under that uncertainty. Next slide, please. This is where we shift from the context of resilience into the actual problem. And on the top, do you see this is how planning is actually typically done today. Hazard studies are usually siloed. So for example, flood is analyzed separately from wildfire or wind. And the results are hard to compare because each study uses its own different assumptions, different metrics, and different methods. And a lot of the planning is still deterministic or scenario limited, meaning you're not really capturing uncertainty in a meaningful way. Now compare that to what actually planners need. They need to compare across hazards, understand risk more probabilistically, and most importantly, directly link those results to the investment decisions. So the gap here is not in our ability to model hazards. We're actually pretty good at that. The gap is in translating those results into decisions. That's why I like this line at the bottom. We don't have a modeling problem. We have a decision translation problem. And that's where ERAD comes in. It acts as a central engine that takes the hazard inputs, models the asset level impacts, and produces output that can actually support decision making. Next slide, please. This slide shows what planning should look like when everything is connected properly for resilience. You start with hazard characterization and then move into impact assessment, investment prioritization, and finally risk and cost benefit analysis that leads into performance evaluation. If you look at the tools shown below, we already have strong capabilities across each of these steps at NLR, tools like Super CC for hazards, Reopt for optimization, and others. We will have a link to all of these tools at the end of this deck. But the key piece here that we're focused on today is ERAD, sitting right in the middle at the impact assessment stage. This is not just a pass-through step. This is where hazards actually get translated into asset level failures, system impacts, and probabilistic outcomes. So ERAD is doing the core modeling work that connects the upstream hazard data to the downstream investment decisions. Without that layer, you will have tools, but no consistent way to connect them. And with ERAD, you have a coherent workflow where each step feeds into the next in a more meaningful way. Next slide, please. Okay, this slide brings everything together for the intro. Existing studies today are often very hazard specific and are hard to compare. Distribution grid systems, which are the most impacted, are also the least consistently modeled in this context. And most importantly, there is no consistent way to compare investments across hazards, assets, and scenarios. That is the gap. ERAD was built to specifically address this, not just by connecting tools, by acting as the central modeling layer that translates hazard inputs into asset level impacts and then evaluates how investments perform under those conditions. So when we say ERAD bridges hazard modeling and investment decisions, what we really mean is that it enables a consistent, probabilistic, and an asset level way to make those decisions. And that's what makes it fundamentally different from how planning is typically done today. With that, I will pass it to Adil to fill us in more on the tool itself and some use cases. Thank you.
Hi guys, thank you. My name's Adil Latif. Thank you guys for the great introduction. I've been here at NLR for the last 10 years, and I'm the lead developer for ERAD. Uh, and today I'll walk you through the rest of the presentation. I'll start by talking about what ERAD is, what the design philosophy is. We'll talk about what ERAD is not, and then towards the end, we'll walk through a couple of use cases, and then towards the end, if you have some questions, we'll try and answer them the best we can. Next slide, please. So what is ERAD? ERAD is essentially a simulator that allows you to simulate an interaction between the hazard system and the asset system, right? A hazard system can be something like a hurricane, a wildfire, a flooding event, or an earthquake. The main capability that sets ERAD apart is its ability to simulate multi-hazard systems. So think of a hurricane, right, where you might have a storm surge as well as high wind vectors that impact assets differently. So you want to be able to capture both of them to accurately model how an asset is impacted. It is asset centric, which means you're able to go down to the very last asset in whatever asset system you want to be able to define. And I'll get to that in a second. We'll explain what that means. And again, as guys we said, it generates probabilistic results. And the idea here is you're able to generate Monte Carlo samples and get a very good holistic understanding of what resilience vulnerabilities exist within the distribution system. Next slide, please. One thing we wanted to highlight is that ERAD is interoperability first. Interoperability is not an afterthought in the design decision. So we built ERAD on top of grid data models, which is a set of foundational models for the distribution system developed by NLR. And the main advantage of being able to do that, integrating with GDM, is it allows us to connect with a lot of the larger ecosystem that exists for the distribution tools at NLR. It is artificial intelligence native. I'll extend on that in the next slide. Next slide, please. So I've talked about the ERAD design philosophy. One of the main drivers behind the design philosophy is the extensible nature of ERAD itself. So I talked about the hazard system and the asset system. These are very general terms, and they're by design. What we want the users to be able to do is if they come up with a new hazard system, they should be able to integrate that with the ERAD ecosystem. Uh, we at this point have implemented asset system for power system for both transmission and distribution system assets. But if you were to like, if you had fragility data for buildings, for example, or other infrastructure, there is nothing stopping you from building another asset system and trying to run the simulation and understand what an impact of a given hazard on a given asset system is going to be. So it is extensible by nature. You can extend the asset system, the hazard system, the fragility models, everything is up to the user itself. Next slide, please. Uh, I wanted to talk about the larger ecosystem, and I talked about the interoperability. NLR distribution suite, we've got the link down at the bottom here, is a tool of interoperable tool. It's a set of interoperable tools that all built on top of the GDM foundational models. Shift, for example, builds synthetic distribution models. Ditto is a transformation tool that allows you to convert distribution models from one format to another. And then JDM being the foundation layer that connects all of these different things together. We've got all of these different tools have an MCP layer already attached. They're all agent ready. And what that really means is that you're able to build simulations and run workflows by using simple prompts like something as simple like say, build me a hazard model for Hurricane Carla and run a simulation for my given distribution network. So things like that can work. And what this interoperability allows you to set up scenarios faster, set up repeatable studies, uh, and better understand resilience decisions. Next slide, please. So what ERAD is not, I want to kind of spend a minute here and kind of highlight like the limitations of ERAD. So ERAD is not a fully featured hazard engine, right? We do have interfaces for all the different types of hazards we talked about. These are mostly very lightweight. They come from literature. We've referenced them in our documentation. But if you want to run a very high fidelity hazard propagation model, yeah, the built-in ERA tools are not the way to go. So ERAD was built to be extensible, which means you are able to extend or you're able to connect ERAD with external tools. We've got a few tools that we've already connected to, EGSIM, for example, PyWatershed, uh, uh, Forefire are a few examples of like very high fidelity hazard engines that we've integrated with. But if you want to be able to use a very high fidelity hazard engine, make sure you use an external tool and an interface that we ERAD rather than using the inbuilt propagation models. ERAD is not a tool to build fragility models. ERAD does not build fragility models, but it allows you to bring in your fragility models from external tools. So if you build some fragility model using say some ANSYS analysis, some finite element modeling, you can bring those models, you can incorporate them into your ERAD study and run the simulation that way. Next slide, please. Going forward, I'll talk about two use cases. One thing we wanted to highlight, and I think Gayatri did a really good job there, was kind of highlight that uh, ERAD does resiliency modeling, right? But there is this need to go from modeling to decision making. And we wanted to kind of highlight two use cases which we've done exactly that. Uh, uh, so uh, so this is the first study. So the Iowa flood resilience assessment using ERAD is the first use case that we've done where we looked at impact of flooding on distribution assets for the state of Iowa. Iowa, if you don't know, has 19 presidentially declared disasters in the last 50 years. So it suffers from floods a lot. Iowa as a state, next slide, please. Uh, Iowa, Iowa as a state has a good understanding of where uh, flooding happens. What it doesn't understand is how, like, what distribution assets are most vulnerable. So that is something what that we wanted to take and get an understanding of. Uh, uh, what we really wanted to understand was what assets are most vulnerable. Not And one thing we wanted to highlight here is that not all assets are going to fail at equal rates. So even if there are assets that are in a flood zone, not all of them have the same risk profile, right? And that is what kind of ERAD allows you to do, is kind of look at individual asset and look at calculate the stresses for individual assets and try and figure out what the resiliency impact is on that asset for these different stress vectors. Next slide, please. So here we talk about the Rock Valley use case for Iowa. Uh, this in this study, what we wanted to kind of highlight was this is a very interesting use case. In this use case, we've got two load main centers, one at north, you see at the very top, and one at towards the center here. Uh, we've got distribution assets that are within the 50-year. There is significant amount of distribution assets that are within the 50-year uh, flood zone, and then the substation itself, in this case, was within the 100-year flood zone. Uh, and again, because of the profile of the land, because of the way flooding happens, again, wanted to highlight here, not all assets have the same probability of failure. And what ERAD is essentially going to do in the next slide that I'm going to show you is calculate uh, resilience probabilistic, like resilience of each score for each asset, if it fails or not under different scenarios. And then what we're going to do is try and figure out an investment strategy that works for all future scenarios. Next slide, please. All right. All right. So for this case study, what we did was we looked at all the different flooding scenarios going from 2-year flood to 500-year flood. So probability of an event happening 50% of the time versus 0.5% of the time in a given year. Uh, in in green, you see all the different distribution assets. The light pink color that we see on these plots are assets that are outage under the given event. So, for example, a 2-year event, a 10-year event, or a 100-year event. You see as the severity of the flooding event increases, there are more assets that get outaged. The red assets are the one that are optimization workflow essentially uh, proposes to invest in and harden. I should have given this context in this study. What we looked at were three different categories that we wanted to look at that we can make an investment in. Suppose that we can harden, so going from class 1 to class 4, class 4 to class 1. We wanted to look at undergrounding as an option. So if there are assets that are really vulnerable, does it make sense to underground them? And then finally, we wanted to we wanted to check what would be the impact of adding a flood wall to the substation itself. And again, you see there are load centers at the north, and you see there are some load centers towards the center. What the optimization does is it actually looks at all of these different probabilistic events going up to the 500-year event, does multiple samples for all of them, and comes up with an investment strategy that works for all future scenarios, or at least works best for all future scenarios. Next slide, please. So what actually drives resilience values? So one of the key takeaways, some of the key takeaways are in the slide. So pole upgrades, for example, are low cost and frequency selected. They provide incremental resilience benefits. So what we saw was as we go from upgrade poles from class 4 to class 3 to class 2 to class 1, we saw incremental improvements in resilience scores. Uh, Undergrounding has high capital costs, but has longer term benefits for severe scenarios. And then substation is a critical point of failure and had the highest impact. And of course, given the radial nature of distribution networks, if the substation fails, there is loss of load for everybody downstream. So it becomes the critical point of failure. So investing in a flood wall kind of became mandatory in the scenario that we worked in, that we looked at. Next slide, please. So the next use case I'm going to present is a little different. It's going from resilience to an actionable, uh, uh, something that is actionable. In the first use case, we went from resilience. How do we integrate investment decisions by incorporating resilience in them? In this case, we looked at recovery. This use case, I wanted to just give you some context, was built for DOE and other partners to demonstrate NLR's capability to model multiple hazards at the same time, and kind of understand how these compounding uh, 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 hazards kind of impact the distribution system in general. Next slide, please. So in this use case, what we're going to do, and I'll go through a couple of slides in a second, is we're going to actually have a hurricane that is going to be simulated that goes through Texas. Uh, it has some impacts on the distribution system. Some assets are outage. All of these are modeled in ERAD. So ERAD was used to kind of identify assets that are vulnerable, that are going to get outage. This is a mean of 100 different simulations. Once the assets are outage, the simulation then kind of shows you the system recovering. There is a third party actor that kind of uh, uh, outages some wind turbines to kind of slow down the recovery effort, essentially, right? So the idea is incorporate both a natural hazard event and cybersecurity, a cyber event at the same time in the same simulation to showcase capabilities that can be realized within the NLR software ecosystem. All right, next slide, please. All right. So on the top left side, you see Hurricane Carla, 1967, propagating through Texas. In the middle slide, what you see is there are some assets, the distribution networks that are outage as a result of high stresses on some distribution assets and assets failing, right? On the right top, you see loss of load over time. Uh, and then towards the bottom, you see some critical infrastructure that goes offline, right? These might be power plants, these might be EV stations, these might be gas stations, anything that people typically use to evacuate in a given scenario. So ERAD was done. ERAD was used to kind of do this first part of the simulation where you're looking at those outage areas. So ERAD was used to kind of understand how a hurricane impacts the distribution system and assets are outages. Next slide, please. Uh, in this video, what you're going to see is the recovery effort itself, right? Once the assets were outage, we had a third tool called Cadet that we presented on last time. Uh, and what we're showing here is an optimal recovery. So what the idea is, we're trying to kind of incentivize recovery of assets that is going to decrease loss of load. And then we're trying to do it over time, and Cadet is used to kind of come up with an optimal strategy that allows us to recover to 100% loading before the event. All right, next slide, please. So what is ERAD? I wanted to kind of spend a minute here again. ERAD helps utilities prepare for worst case scenarios, right? As under uncertain situations, under uncertain conditions, utilities want to better use resources that are limited. They want to understand how these resources can be best utilized and allow us to plan and prepare for a world that is not known. And that is kind of where ERAD kind of fits in. It allows you to understand uh, the impact of different stressors on distribution assets. It allows you to understand what the resilience score is that can then be translated to either investment decisions or optimal recovery formulations, and help utilities better plan for uncertain scenarios. Next slide, please. So ERAD is an engine. It's not a one-off model. It is built to be extensible. You're able to interface it with other external tools. It is designed to be plugged into existing analysis pipelines and partner tools. We showed you examples of ERAD working with Cadet and other tools. Uh, the current default asset system focuses on the power distribution system. And again, as I said, it is extensible, which means you're able to integrate other types of domains like building water, telecom, or any other domain you wanted to add, you can build models for that and integrate into the ERAD ecosystem as well. Next slide, please. So ERAD evaluates risks across hazards, assets, and scenarios in a way that unlocks defensible investment decisions, taking into account the uncertain nature of the future. It allows you to better align between cost, reliability, and resilience outcomes. It enables you to plan for uncertainty, not just the expected conditions. I think that is kind of the main takeaway from this slide. Next slide, please. So how can you access ERAD? So ERAD is a Python package. You can just do pip install enroll-erad to install it on your machine. The documentation is available at nlr-distribution suites.github.io/erad. There is a paper that is on ERAD that is hosted on the same GitHub repo as well. Have a look at that. And then the adoption path, we do have a Discord channel. If you want to come join there and ask questions, you're more than welcome. We do have integrations for a few different tools at this point. The ERAD ecosystem is growing. It is undergoing the open source process right now. So once we have that open source, we will announce this in the Discord channel as well. All right, thank you. I think that is the end of my presentation.
Thank you both for your wonderful presentations. We will now be entering our Q&A portion of today's webinar. We did receive a few questions in advance, so I'd like to start with those. Some of these were covered throughout the presentation, but it would be great to just highlight those answers. The first question is, can ERAD be adapted to other types of loads?
So other types of if there are other types of loads, you can extend the current library, yes, and then you can attach fragility curves to individual properties of a load model. Whatever load model you want to bring in, yes, we can support that.
Great, thank you. Another question that we received in advance is, are there any special connections to Biocar?
I am not familiar with Biocar. I mean, if you're able to give me more context, I'd probably answer that.
Okay, if whoever asked that question in advance is joining us live today, please feel free to offer additional context. Otherwise, we can move along to additional questions. There's a question here asking where AI fits in these various scenarios and what is the best practice for hardened EMP or GMD.
So AI, a few different places. So I talked about the NCP layer, right? So you can have a multi-agent workflow set up with ERAD today, even with the rest of the NLR distribution ecosystem that we talked about. So you can actually go from one tool to another, say convert this distribution model to whatever format you want, run the simulation in ERAD. All of that is possible today. Other avenues that I've seen AI being integrated is the hazard modeling itself, right? The propagation. We in other projects we've been using AI like deep learning models for say wind propagation. So there are many different avenues where AI can be leveraged.
Great. Are there any best practices that you can share to be applied to ensure customers benefit in the most cost-effective way from the investment opportunity?
Yeah, I can take that one. Usually cost-effective outcomes are coming from comparing investments across hazards and scenarios. So if you evaluate them by themselves in isolation, you're not going to get that. and you want to target the assets that are driving the most risk and hence the outages. So you want to avoid any type of over or under investing and have a balanced portfolio of solutions for investments. ERAD can help with that, where you can model multiple hazards, multiple investments, and identify the benefit of those investments in avoiding those outages with the objective function formulations.
Great, thank you. Another question we've received during today's webinar is it possible to predict about overhead pole infrastructure through ERAD?
Yes, yeah,
No.
that is exactly what use case one was. So we kind of looked at vulnerability of the poles to flooding events. You could do it for other hazard types. You can have class A, B, C, or whatever different types of poles. So yes, that is all doable.
Great. Where would the potential investments to make be entered and modeled within the ERAD system?
So you would define them as changes to the asset system properties or configurations. So if you're, say, upgrading a pole type or undergrounding a line or protecting a substation, you just need to take that asset property and kind of change it to what your upgrade would be. And then ERAD will then run the simulation and evaluate how those changes are affecting the failure probability.
I will say this, like to get the most value from ERAD, you have to interface it with another tool, right? So the use case that the Iowa use case, for example, we interface ERAD with Cadet, which is a capacity expansion tool. So ERAD generates the outage scenarios, and then Cadet looks at all of those scenarios and kind of comes up with an investment strategy, right? So ERAD, the most value you would generate from ERAD is by actually building a complete workflow. Like in silo, it's not going to give you a lot of actionable information.
And that leads well into another question we've received. Can ERAD be interfaced with AI models such as Claude or ChatGPT?
So if you're asking about driving, yes, because the MCP server can be served with any AI with any LLM, right? So as long as you have an MCP orchestration tool, so be it Cloud Desktop, be it something else, as long as you're able to add our MCP server to your MCP orchestration layer, yes, we can use whatever LLM to drive the actual simulation.
Great. And you've talked about the connections to other tools. Are there any specific connections that you'd like to highlight or use cases connected to connecting ERAD with Rev?
Yeah, I think the most common use case we've had is using ERAD with some sort of optimization problem as the second part. So we've got so kind of builds like I talked about the different integrations, right? We have integrations to say uh, for fire, which is a fire propagation tool. We've got integrations with say EGSIM, which is like a seismic uh, like physics-based seismic tool. It does a very thorough seismic simulation, very like robust high fidelity simulation. So it's all about the complete. Like I think in this day and age, a single tool does not do everything. Like most value is to be had when you start to connect and build out workflows that make sense. So if, for example, it's fire propagation you're interested in, maybe interface with for fire, let the file propagation be handled by that tool, and then you have the asset system, and then you understand the vulnerabilities and what the distribution system is, and then have a downstream application that kind of looks at all the possible scenarios that ERA generates and optimize it for either recovery problems or like investment problems or whatever those problems might be.
We have another integration question. Is ERAD fully Python or is it interoperable with Julia or others?
It is fully Python. With GDM, which is the underlying library, is Python, and ERAD builds on top of that. So ERAD is fully Python at this point.
Great. And who would want to route projects through this platform instead of staying inside an OEM ecosystem or working directly with aggregators such as Energy Hub?
Sorry, could you repeat that?
Yep, who would want to route projects through this platform instead of staying inside an OEM ecosystem or working directly with aggregators like Energy Hub?
I think if you want to have, I would say this, right? I've talked about like if you want your decision making to look at all possible probabilistic, like having look at like a probabilistic feature and incorporate that into your decision making, ERAD, that is where ERAD kind of fits in. Uh, I will say this: I've had a few chats because I've been trying to get some data on fragility from uh, say uh, insurers and reinsurers and stuff like that. So we've had some chat, and one of the concerns they've had is that a lot of the tools they have are proprietary in-house, which means they're not even able to compare against other proprietary tools. And what they wanted was a tool that allows them to like bring in their fragility models, keep them in-house, but be able to compare with existing literature or be able to compare against other third-party tools. And that ERAD kind of essentially provides that kind of capability as well, right? So that is something that that avenue is something that we're actively looking into, like helping out insurance and reinsurance companies kind of compare and contrast between different models, and and be able to come up with like try and figure out like what works best. Like because when we talk about fragility curves, right, there is a lot of engineering biases baked into that fragility model. Your analysis is as good as the fragility model itself that you're incorporating into your simulation, right? So a lot of time and effort needs to be spent cleaning that up and to get full value from the simulation that we do.
Thank you for that detailed response. Another question is, have you tried doing extreme frosts, natural gas pipeline infrastructure hazard modeling,
We
maybe
have not.
considering replicating past winter storms in Texas?
No, so the only so we only as I said, so the only asset system that we built models for now is the power system model. So no natural gas representation at this point. No other asset system representation at this point.
And what sort of adoption are you seeing for this tool or approach across utilities, consultants, OEMs, etc.?
So ERAD itself has been used for very, very large efforts. So the LA 100 was the main effort that this tool was initially developed for. So at LA 100, if you don't know, is a very large scale study where they wanted to look at impact of different types of hazards across their entire territory. We ran millions of simulations for them to be able to get a holistic understanding of what risks exist within their distribution network and how to mitigate them. So yes, ERAT has been used for very large scale studies, and so we've and then for Iowa again, that's the second use case we did. We've been using it for other studies as well uh, the across the portfolio of projects that we have. External adoption, I don't think we've really focused on that at this point. What we've really been trying to do is improve the workflow, make sure that the models we have integrated make sense, are validated. So that has been the main effort in the last couple of years. I think maybe in a few months we're going to be at a stage where we start to really push it out and try and increase the adoption for the tool itself.
To add to that question, all of these studies have been done, for the development of ERAD. Now that we have a concrete tool, I think this sits very well within the planning domain in utilities. If they are looking into understanding what their investment portfolio should look like, given suite of hazards that they are trying to address, I think ERAD is a tool that can help them with the combination of other tools within the NLR distribution suite that we've talked about today. The most recent example is the one Otto talked about in Iowa, where he looked at flood, but we have been looking at other wind and wildfire cases in parallel. We're just not able to share that at the moment with you all. But yes, it fits within the planning paradigm and utilities. There's a suite of questions about the tool itself. The 6 questions, Sophie, I can kind of start answering them. The question on are solutions in ERAD predefined? There is a basic set of default assets and configurations, but we do not have a fixed menu of solutions. It is flexible. We can build a solution model if needed within ERAD. Can users add options? Yes, it is a key feature. We can the users can define their own investment strategies by modifying the asset attributes, fragility curves, or any type of system configuration. The other question was, how is cost quantified? Cost at this point is user defined. You can attach the cost assumptions to each investment options. This could be based on utility data, literature values, or any type of estimates. Maybe Otto can talk a little bit more about cost solutions that we've been developing at NLR. It is a database of options that we have been building on. Another question there was, is evaluation based on cost or resilience index? I would say it's both. ERAD generates impact and risk outputs, and users can combine those with the cost to do cost benefit or cost effective type of analysis. What metrics are used? Typically, in the studies that we've done, the metrics included things like probability of asset failure, number of assets damaged, outage impacts, and any customer level type metrics. Are they based on standards? They are generally, our metrics are aligned with the common utility and resilience planning practices. We have a whole suite of information available on our website on the type of resilience metrics we evaluate. But ERAD itself is flexible, so you can define metrics based on your planning context. I think that was the set of 6 questions there.
Thank you for answering those. If you have any more questions, please send them in so that we can get to them today. We do have 1 or 2 remaining. One is, where do you sit in the control stack? Are the system of record for dispatch, or are you optimizing on top of OEM or DERMS constraints?
So we're not operating on top of OEM or terms constraints at this point. What we're doing is the GDM itself is a physics-based model, so it defines the physics of the system itself, which is the base underlying model, right? What we're doing is understanding how an external event impacts the outage probability of a given asset, right? ERAD, this gives you that information if an asset is outaged or not, right? What we do next is tie it with other tools downstream. So for example, Cadet, which is capacity expansion, we give it a whole bunch of, if you're able to share the screen again, going back to the 2 years, 10-year, 100-year flood, I think that kind of explains it best. So the idea is, once you have a set of like probabilistic outcomes modeled, what do we do next? And that is what Gayatri said, like having this information is useless unless you're able to kind of map it to an actionable outcome, right? So that would be either investment decision, or that might be like how you recover optimally after the given event. So all of those things is what the ERAD kind of helps with, right? You generate a bunch of possible scenarios, outage scenarios, and then you tie it with another tool in a given workflow that allows you to come up with an investment decision based on some optimization formulation. In the use case we had, this was a 2-stage optimization formulation, where the first stage kind of defines what assets are going to be upgraded. And then we had timelines switches, by the way, as well. So we did kind of look at like, okay, what timeline switches can we can reconfigure to kind of maximize like uh, minimize lost load essentially, right? So we had a two-stage stochastic optimization problem, and the investment was driven by that formulation essentially.
Great. I think we have just one final question asking, can we use ERAD instead of pole foreman to design overhead pole location?
Not
No,
really. They serve different purposes. I think pole foreman is a design tool for sizing poles or even placing poles. ERAD is the resilience analysis engine, and so you would use pole foreman for designing your poles, and then you would use ERAD to assess the risks and impacts, and what the design choices that you made in pole foreman, whether the design choices you made are resilient under extreme events in ERAD. So yeah, different tools.
Great. We have had one additional question come in. Which 2 to 3 upstream metrics do you want ERAD to officially provide next? For example, critical load at risk or expected unserved energy, and what acceptance criteria defines being ready? For scale, do you want to standardize on many feeder level ERAD instances orchestrated globally or evolve toward one larger uh,
because
ecosystem?
I forget the second piece. I'll try and answer the first half and kindly repeat the second part. Uh, so metrics, I think the way we've designed ERAD is that you define the metrics. I think the question itself talked about two very specific metrics. So expected lost load. So we can calculate that. So that is essentially what we did for the Iowa study. Uh, we already do that. And then the second, we talked about the critical loads, right?
Mhm.
Lots of critical loads. So that is exactly what we did. That's the second case study we showed you, where we were looking at a lot of critical loads. We had individual weights for different types of critical loads. And then when we were recovering, we tried kind of weighting the optimization based on like what load we wanted to make sure was recovered first. I think so, so don't think of ERAD as a single tool that is going to give you everything. The way we use ERAD is in a given is in a workflow, right? And that is where it generates most value. So you have to have some sensible upstream tools. You have to have some sensible downstream tools, and a whole simulation suite that kind of makes sense to get value from, like the results generated from ERAD.
Great, thank you. Well, unless any additional questions come in, I believe that concludes today's session. I will thank everyone for attending today's Powered by webinar focused on ERAD, and a quick plug for our next Powered by webinar, which will focus on DGen and will take place on May 21st. I'm going to drop the registration link in the chat in case anyone is interested in attending that. Do either of you have any final words before we conclude today's session?
Thanks, everybody.
Thank you all for joining. If you have any questions, reach out to me either on the Discord channel or on my email.
Thank you, everyone, and see you at the next session.